Electrophilic additions to conjugated dienes. So dienes, like other pi systems like alkenes and alkynes, are nucleophiles. And as a nucleophile, it's going to react with an electrophile like HCl. So if we're looking at the hydrochloric acid, the hydrogen is partially positive and the chlorine is partially negative. And so the first step of this mechanism would be the attack of one of these two pi bonds on that positively charged hydrogen. And then we will break the bond between the hydrogen and the chlorine. And so the additional thing that we need to consider here is, because this is a conjugated system, that means that our carbocation is going to be resonance stabilized. So our carbocation will have resonance. Okay, so I'm going to draw that initial carbocation. So I'm going to add the hydrogen to the end of the chain to give the more substituted carbocation. And not only will it be more substituted, it's allylic. It is on the carbon adjacent to an alkene. So here is that initial allylic carbocation. And so this cation does have resonance. We can draw the resonance structure by moving this pi bond. And so we're now forming a pi bond between carbons 2 and 3. And that puts the positive charge on the end of the chain. And so from these electrophilic additions, we can see two possible products. We can see a product where the chloride nucleophile attacks this carbocation, or we can see a product if the chloride nucleophile attacks the end carbocation. So here are our two possible products that can form. And so I'm going to redraw the cation so that we can show how the nucleophile attacks. So here is the first cation that forms. And if the chloride nucleophile attacks this carbon atom, this is the product that will form. And so we call this product the 1,2 addition product. And so these numbers are indicating where the hydrogen and the chlorine added relative to each other. So if we number the carbon chain, on carbon 1 is where the hydrogen added, carbon 2 is where the chlorine added. And so that is why it is called the 1,2 addition product. If we look at the other carbocation, or the other resonance structure, we could also have a chloride ion attack that. And that would give us this product. Okay, and in this case, if I number the carbon chain the same way, the hydrogen's still added to carbon 1. So there's carbon 1, 2, 3, 4. This is known as the 1,4 addition product. So how do we know which product is the major product? That depends on the reaction conditions. So if we're wondering what is the major product of this reaction, it depends on the reaction temperature. So it depends on temperature. So at a low temperature, this is what we call kinetic conditions. This means that the product that forms the fastest will be the major product. The product that forms the fastest will always be this 1,2 addition product. And so the 1,2 addition product will always be the major product at low temperatures. If you conduct the reaction at a higher temperature, So you can think of a higher temperature conditions as having more energy. And so what you're going to have here is it's going to settle out, your system will settle out, and you will see the major product being the most stable product. And if we are looking at a product like these ones that are alkenes, the most stable product would be the most stable alkene. And so if you're looking for the product under higher temperature conditions, you need to look at both of those and say which one is more stable. This second product here is a di-substituted alkene. So that is the more stable of these two alkenes.